That's a bit what we're going to do. Well, welcome everybody. My name is Ander. I'm Spanish, but I live in Amsterdam and work at SURFsara. So, who are we then? SURFsara is the National Supercomputing Center for the Netherlands, high-performance computing center, and we are based in Science Park. We do supercomputing, we also do high-performance computing. So our history brings us to be the company that we are today, from the original department that we were, computing department, from 2 or 3 universities in Amsterdam. So some history is still there. We are now in this boomerang-like building in the Science Park. This is our main entry. And since the beginning of this year, we are part of SURF, which is a bigger umbrella for national research in the Netherlands. This is what we have as an infrastructure. So this is SURFsara's infrastructure. Our national supercomputer, we just had it inaugurated this summer. We have the LISA National Compute Cluster. We have some history with the grid. We are part of the European grid infrastructure. We also do quite a lot of work on visualization. We are handling these networks, among others, so we have heavy duty there, and we have innovative infrastructures, among others Hadoop, bHub, and of course the cloud. The cloud is something that came to us as a way to provide answers that we couldn't offer with the rest of the infrastructure. So here's a bit what we're going to have a look to. We have first what we have. We're going to talk about what we have. Then the user experience, it's a bit tricky there because it's what we consider ourselves as a user and then what our users feel with OpenNebula, because they get to see OpenNebula. And then how we've done it. And we were already on the first part. So this is the main workhorse for us. We provide services to the scientific community in the Netherlands. Scientists are good at their fields. You know, they are great biologists. They are great astrophysicists. They are at the cutting-edge research areas in their topics. But then they're not system gurus, necessarily. So we have to provide them with a way to solve their problems. You know, modeling, computing, handling large data, usually dirty, non-structured. But we don't have to. We don't want to have to do all of this for them. But then we still need to give them all of these features: flexibility, errors, places where they can test, show, and where they can cooperate among themselves and then with people out of their groups. So it's not that easy. Well, we have grouped our different systems. We've tried to classify them somehow. We can elaborate about this a bit more later if you want. But mainly, the cloud fits there. It has our HPC Cloud is meant to be good at processing, have a certain amount of processing. We are not considering providing good input-output, so not specific data. But then it has some data approach. And you need to remember that we are coming to the cloud after our history within the grid. And the approach that they had in the supercomputer as well, which is running jobs. Now, we don't want to set up an infrastructure for them to run jobs. They have other infrastructures for that. But if they want to, they should be able to. Mainly MPI jobs, for instance. This is what we've had in mind when we devised the cloud. So what do we want to offer our scientists, our users? Well, we want to give them their own world. We want them to do their own thing. But then we want to make it easy for them. And to connect. So we offer infrastructure as a service. We provide these via OpenNebula. And something that's very important for us, the network filters. Because we want to make sure that their data or their space is theirs. So to our extent, to our knowledge, Obama hasn't tapped into our services yet. Well, this is one of the things we want to keep trying to ensure. Now, we want to allow cooperation. So what this tries to depict here is that if you are a user from our cloud, you have your own world, as we saw before, which is the jar in this picture. You can run one machine or many machines. You can connect them the way you want. You can have many users, so you can have your group cooperating. You can connect to the outside world or the space if your jar is your world. And then you should be able to cooperate as well within our cloud even. So that's why we have different jars. And this is what we've been seeing so far. Now, like I said, we want high performance computing. That means we want to allow reasonably big nodes. We want these nodes to be used if the users set up their infrastructure so that they can run MPI jobs. That means we need a fast interconnect. We need different virtual machines to be able to talk to each other and scatter data, get it back in an MPI-like computation system. And then we want the user to handle all of this, like I said. So we have OpenNebula, but tweaked. Now, when we started doing this, this was 2009. I can't even remember which version we were using at the time. At some point, we even thought about implementing something ourselves. But then OpenNebula came to the rescue. Now, we only had to tweak it a bit. What we call projects map reasonably well to the groups that OpenNebula offers. The end users have to use that. Like I said, they're not IT specialists, so we had to provide them a way to understand what they can do, or a reference manual. So we provide documentation. It is very important for them to know how the system status is, so whether they can actually run big machines or smaller machines. We provide a way for that. Network filters for us, we offer every group their own private network, so they can have their machines connected within this internal network. And that's important because then if you consider sensitive data that they may be using, say for instance patient data from hospitals, well, you want to make sure that they have a way to protect that. We had to come up with a way for them to share data now. To understand how we charge our users, they ask for a certain amount of resources. Namely, this is the project, this is a problem I want to solve with this data, and then we estimate a certain amount of core hours that they may require for that, along with the amount of space that they may need for storage. Because we don't want to have many physical resources idle, well, we try to buy only the hardware that we need. So we work on a best effort basis, and we encourage our users to shut down their machines when they're not using them anymore. Now, they still need to be able to keep the data. Maybe they want to transfer data here and there. So that's why we came up with the solution of what we call Virdir, which is external storage. Image transfer now goes through Virdir as well. And also very important for us, now trying to explain, say, a psychologist, what a template, what an image is, how to relate that, how you instantiate it, that's quite difficult. So the first way to go with this is we recommend them to use the wizard. So we've developed a wizard. With a couple of clicks, you can have your virtual machine up and running with a given set of characteristics that you can choose. If I have time, I will show you later. Of course, internet allowing us here. Now, all of this plan was great, but we found out that many people were trying to run, it was so easy for them to start up virtual machines that they decided they were going to start running servers on our cloud. Now, having a full core of a reasonably powerful infrastructure idling because it's only waiting for somebody to ask a web request, for instance, we thought we could do something about it. So we came up with the Cloud Lite this year. They are smaller nodes. We allow CPU overcommit in a controlled manner. And it's precisely meant for this, for interactive services. So services that are there running, maybe doing no computation at all, just waiting for something to ask that. Accounting is also very important for us. We need to be accountable to our users, but also to the government, because we are a private company operating with public money. So the taxpayer may come to us and say, what are you spending the money and paying on? Well, we had to have accounting. So we create user accounts. We ask users not to share their user accounts. If they need more user accounts, we can create more user accounts. We monitor CPU time, we monitor storage, and we monitor VirDir, as I told you. And I can tell you that so far, since 2009, we've already handled 200 requests, more than 200 requests. And we've had more than 21,000 virtual machines, which is quite big for us, I guess. A request here could map to a project. That's what I told you before. When you want to access our infrastructure, in particular our cloud as well, you send a request to us. This is a a scientifically solid request, preferably. You explain your project. This goes to a peer review, and if there's a reasonable case, then we can accept, or maybe the committee, may decide that the cloud is not the best infrastructure, maybe the grid is better, so we act as counseling there. So that's why you see a difference there between projects and requests. And then a request may be just to expand a different project, an existing project. So that's also there. Now, important figures, the amount of users. We are offering OpenNebula. At the beginning of September, we had 180 active users. That means 880 users can actually, at some point, start working together on OpenNebula. So it's quite a milestone, I guess. Also, congratulations to the OpenNebula team, because this goes well. We've never had this kind of trouble. VirDir, it's just storage. We had 30 terabytes of storage in September, but this could change any moment. People may start deleting or adding files. It's no big deal. Over CPU time, we have more than 530 years already computed, which is quite a big number in 3 years, 4 years. And we've had already more than 2,600 images. It's quite okay. And this is where our users are working. They work in biology, genetics, informatics. Well, you can read the list there. And what we look for is to adapt the users, or look for cases that can actually benefit from the cloud. And we focus on users who actually manage to get this, and then we look at what they're doing, and we also learn from them. So there are many users that are benefiting from the fact of having a self-service approach, where they can do whatever they want, almost. There are a couple benefiting from the elasticity that the cloud offers. So they are able to send or start up machines as their processing requires, and maybe based on the load that they may have at the time. Shut them down. They are mainly using Condor at the moment, HT Condor. The cloud has proven to be a great solution for situations where users want to have their own licensed software, because we don't want to handle that for them. We don't want to have to buy licenses for, say, Windows, for instance. If they are in a research institute, university, they probably can get it from there, so it's fine. Successful stories also with workflows. Especially biologists come to mind now. They have, in their fields, they have studied ways of processing certain type of data, so they can share this. They just need to provide different data. So we even have people providing a service for this on our cloud. And they're also benefiting from elasticity. So it's a great showcase. And some people are actually indeed using intensive compute, so MPI jobs. And this is how we do it. This is the hardware that we have. We have 19 high-performance nodes. These are the big nodes. They have 32 cores each and 256 gig RAM. To make it easy for a user to choose and for us to share the resources, when you choose a CPU, so a core, then you also get 8 gig RAM. And we're also always reserving 6 gig for the operating system running there. So if you get a 32-core machine, then you will not get a 256 gig, only 250. And that's proven to be more than enough. And the balancer that we have is also doing well in keeping all 19 nodes busy. So this is important. Each node has four connections, 10 gigabit Ethernet each, to a very nice Arista switch. So if you, and this Arista switch is a one-hop switch between every pair of ports, and that's where the MPI can benefit from. So you can have very fast communication between your virtual machines. Storage is shared, so we have a storage pool. And recently we included the light nodes, 8 cores each. They are not Intel, they are AMD, so we cannot use hyper-threading. We are overcommitting these ones, and they are smaller also in RAM. The important part here is they also have local disk. So if you have to run a reasonably sized database, not a big database, maximum of 200 gig, let's say, then you can run it locally, and it benefits from input-output speed there. And some time ago we measured this. You can get, if all of these are working together, you can get 5 teraflops. And this is a scheme of how everything is connected. In the middle, you would have the switch. Then these 4 connections are for each of the 19 compute nodes, or the HPC nodes. These ones have only got 1 each. And this is what I wanted to show you here today in the presentation. I don't know if you would have any questions. Go ahead. Yeah. The file system is just plain local storage. So when you're running a machine, you just copy the image and you have it there. It's nothing tweaked specifically for that. You saw the pictures. Yeah. The pictures that you saw on top of the numbers in the penultimate slide, it's the actual hardware we have.
Where do you store the users? Do you have an external database for the users, or is OpenNebula?
So the question is where we store the users. We have implemented this accounting system, which is being populated from the OpenNebula and libvirt logs. And we are also taking advantage of that to actually handle the users there. So we have, so our roles are also separated as people working in the cloud. We have the operators of the cloud, and then we have people like me, which are the consultants. So we are in direct contact with the user, and the operators are operating. So they take care of populating that database, but we take care of having the database updated with the user. So it's shared, but we can access all of this together. And when we are going to create the users, we just go to the operator and say, could you please create the users and groups according to what we've defined in this database? Yep.
So you mentioned operators and consultants. So how many people are helping this cloud infrastructure?
Yeah, so the question is how many people we are working in SURFsara in the cloud. Let's say we have half a dozen consultants and 3 operators. Not all of us are working 100% on the cloud, because we have all of the other infrastructure also to maintain. But it's involved people, directly involved people, it's those numbers. Yep.
What's the typical execution profile of the applications? Maybe it's MPI or high-throughput computing?
Okay, so the question is what kind of computing do we mostly have in the HPC Cloud? Well, in the HPC Cloud, we devised it as a good way to run MPI jobs, like you suggest. Like this is what we envisioned back then, so that we would get also people from the grid who fight with certificates and well, an easier step to test things would be the cloud. Now, we have these kind of jobs, but they are not the most of the projects. Most of the projects benefit from having one virtual machine with lots of cores and lots of memory. And like I said, many applications also don't really need many cores, but they need a lot of memory. And because we don't allow them to choose memory on their own, if they want more cores, if they want more memory, the way to get it is by reserving cores. So this would be the main profile. So many cores.
What about the operating system? Because I have heard that this is the only infrastructure that you provide to execute Windows.
Yeah. So we don't execute things for them. So we let the user create their own machines. So as long as they have a Windows license, they can install Windows on their virtual machines. It's, of course, up to the user to have the right license for Windows, as you suggest. That will allow them to use many cores or many network interfaces. You know, that's there. Yep.
You have something like a marketplace where the scientists can get images from CentOS or something else? Or do they build their own images?
We don't have any marketplace, like you suggest. We know that they are working in communities, so sometimes they get, I want the same thing as that one. We've had that one before. But it's up to them to share. What we have is a wizard that can help in creating base images. I can show it to you if the internet is working. First, I would like to clear all the questions. Yeah, no more questions? Okay, let's see if the Wi-Fi is with us. So this is the screen that the user will see. At least we have that. Seems to be working. So this is a dashboard. This is where you would come to create a wizard, an image with a wizard. Simple enough. We've created a set of images. Let's go for CentOS server, which is reasonably small. You can choose. So the names date back to the time when we didn't have the light nodes and the high performance computing nodes. So they could be misleading. They have nothing to do with that. They are only the amount of cores. And you can see that each amount of CPUs comes with 8 times the number in gigabytes of memory. So let's go for a small machine, also a small disk. We have internet filters, as we said before. So this is something that you would come here and define if you would want to. Now the wizard is not paying attention to those. These are for the internet. Now you could choose whether you want your virtual machine to have an interface on the internet. So if you click yes, you will get one. And then we make it easy if you want to run something on port 80. This strange question is only to open that. So let's click on next. And then Windows style, are you sure that what you selected is what you actually want? Okay, let's create C. Now, all being well. Yes, every project gets a certain amount of core hours. This is our project, so our SURFsara project. And of course, we're not paying attention to that. Maybe we established the number back in 2009, and then who knows. So, okay, so this tells us that some information. Now, if we go and look at the images, we should have something with a very long name and the date. That's it. So this was created by the wizard. It also created a template, or not. There it is. And I should have an extra virtual machine. It's not that one. It's refreshing. The Wi-Fi may not be very helpful today. Cannot contact the server. I'd rather blame it on the Wi-Fi than the possibility that our server is indeed not responding. Okay. Maybe, hey, it's doing something. Let's see. There it is. Now, the good thing is that we've also tweaked the images themselves. So the base images have the root account inactive by default. And when you root them for the first time, yeah, this is not going to allow me to get in. So we encourage users to get access to the VNC console for the first time. There is a wizard going on there in single user mode, asking you for a root password, so that we cannot say that we know anything from their machines. Yep. Well, they took a couple of people, some JavaScript tweaking, and let's say in a couple of months ever since the project was conceived, because we didn't come up with this just, okay, let's add a wizard. No, we just thought, oh, we're getting lots of questions from users. How can we solve this? So and then somebody came up with the idea. Okay, let's add a wizard. So a couple of months, it was up and running.
So that is an important obstacle to migrate to OpenNebula.
Not really, because we can provide the images as well. And our users, so it's only when you come new to the cloud that you have to learn everything. So we will migrate. Eventually, it's already in our plans. We wanted to do it everything in November. It may be delayed. Now I've also got the tip from the OpenNebula developers that we should skip 4.2 and go directly to 4.4 since we're at it. Since users are going to have to learn everything, we as well, then we might as well roll everything out as it is and then adapt the cloud later to have the wizard. But of course, if the OpenNebula developers would be able to include this feature on their own, then we wouldn't have to maintain it ourselves. That's wishful thinking. Any further questions? Okay, then we'll call it off. Thank you very much.